recording. All right. Thanks everyone who has joined today for this webinar about design thinking. Whether you have done some design thinking in the past or it's something that's completely new to you, there will be something for you to learn, something for you to share, and something for you to take back to your school or to your own practices. So let me just gather my screens here, and I'm going to share my screen for the rest of the webinar. Give me just a sec to get that set up. All right, I got it. So the topic for today is design thinking, of course, and I happen to have a lot of experience in this particular area. I've been trained as a design thinking educator, and I've helped to bring design thinking into schools and classrooms all over the world, and also with administrators and school systems. So I have like a long history of design thinking and using it even in my own personal life. And so I'd like to kind of just share some perspectives and some tips. And then if you've never done design thinking before, I'm going to walk you through an example scenario to lead you through all of the steps of design thinking. So before we begin, here's just a short agenda overview. Before we get into the meat of the topic about design thinking, I'm going to give just a brief introduction about BSD Education. Then I'm going to talk to you about the history of design thinking. How did we get to using design thinking? Where did it come from? Then I'll share some practical applications, walking you through an example case study of design thinking. And then I'll share some more information about like where is design thinking currently and where is it going? And then I'll share a little bit more about how we use design thinking at BSD Education. Then I will leave room for Q&A towards the end. Now, if you're here live in the webinar and you have a question at any point, drop it into the chat, but I will look at those questions more towards the end of the session. But feel free to put it in the chat anytime. So BSD Education is an online platform and a curricular service that helps students to learn how to use and enhance their digital skills. And that could be with coding and programming or other digital skills such as marketing and content creation. But what makes us unique is that we combine our curriculum, which is a verified and research-based curriculum, along with a digital online platform where students and teachers have accounts. We combine that with our world-class training and support to help schools and to help students succeed in learning how to use and enhance digital skills. And those things can be combined inside of regular curricular elements, or it can be taught as a standalone subject, which could help students from age 3 to from grade 3 to grade 12. So BSD stands for Build Something Different. A lot of people ask us about the name of our company. And for me, what it really means is that we're doing things differently. We're approaching our pedagogy differently. We have designed curriculum differently, and we expect students to use the platform in different ways. And one of those ways is that when students are learning to code and program, they're using real coding and programming languages. So we teach students HTML, CSS, JavaScript, and Python. With those skills, they can build websites, publish applications, build video games, mobile apps. We even have courses on artificial intelligence, virtual reality, building actual e-commerce initiatives, marketing platforms, and soon we will be developing and sharing cryptocurrency, blockchain, and Web3 curriculum. So we're always up to date and relevant and using the real world skills and technologies. So that's why we call ourselves Build Something Different, because we're not just learning about technology like in a textbook, but we're actually building with technology and using it to produce results. But I don't want to, spend your whole time talking about BSD. You came here to learn about design thinking. So I haven't introduced myself formally yet. My name is Mark, and I am the Vice President of Education at BSD. And it's my role to oversee at the company that all of our curriculum is aligned to a high standard and that we have a strong pedagogical foundation that allows our curriculum to be flexible and also for it to be innovative. I'm also currently a PhD student at Chiang Mai University in Northern Thailand, where I'm studying constructionist approaches to learning technology like artificial intelligence. Soon, in the not so distant future, I will have some publications about my research in artificial intelligence and how students use and perceive AI. But let's go on and move to the next part of the webinar where we will be learning about design thinking. I felt that it was really important not to just jump right into the first step of design thinking without providing just kind of a hint of the background and the history of design thinking to better give you a foundation to understand where did design thinking come from and how did it end up in the classroom and how did it end up as something that's taught in the field of education. Well, the codified concept of design as an industry really came about in the late 50s, 1960s. And so what you see here in the image is the cover of Design magazine. And these covers all come from the mid to late 60s. But you could probably tell that just by looking at the color and the scheme of the covers. It kind of has that 60s feel to it. So design was really a section of industry that was focused around manufacturing, engineering, architecture, advertising. So, it was real professionals, professional engineers and professional designers, kind of like needed a space and needed an environment in which they could share, collaborate, and discuss the tenets of design from these different areas of design. So Design magazine was one way for designers around the world to connect and communicate and to collaborate and to share about different examples in design, but also codified methods of design. So it was during this time that these methods started to be shown and used more widely. But it was in the 60s that design became very commercialized, which is why there's a Design magazine and so on. And so this commercialization of design led to an increase in the use of design as a study. But what happened in the late 60s, and if you study the cultural progression of the way of living in America and other parts of the world in the late 60s, there was a big movement towards human-centered approaches. So in 1964, Ken Garland, he kind of took a stand in the world of design, and he said that design shouldn't be so commercial. And so he came out with this thing called the First Things First Manifesto. And it's just his document saying how design has been corrupted by commercialization, and it's only being used to benefit the wealthy, and it's only being used to fuel the factories and so on. And so Ken said, a real design ought to start with the human first. That means that we need to think about the perspective of the human, their needs, their comforts, and design things that are meant to be human-centered and human-focused that would eventually become a service for social good. So it was during the mid to late 60s that this started to really change about the world of design. So designers started to think, instead of just designing a product that I could mass produce and sell in a factory, I should produce and design a product that meets the needs of an individual. And so this kind of philosophy in the field of design led to what we now know as design thinking. So design thinking in the previous eras was more focused on commercialization, and now it's more focused on human-centered approaches. If you want to learn more about the history of design, the Interaction Design Foundation has a pretty good summary, and this timeline is just a screenshot that I grabbed from their website. So if you want to learn more, all of the nuance and the people and kind of how it's evolved over time, please take a look at the website interaction-design.org. But pretty much what we know about design kind of came about from the 1990s. And so in 1991, it says here, the foundation IDEO brings design thinking into the mainstream. And that's how I found that about design thinking, is through IDEO. And IDEO is a worldwide group of designers, and they have codified the design thinking method. But in 2004, the Stanford Design School was founded, which took the design thinking method and brought it into education. So, before that, in the 90s, IDEO was using design thinking globally to kind of bring it into the mainstream in the realm of industry. Okay, so where professionals were using design thinking, and in the early 2000s, the Stanford Design School brought it into education. First at the university level, but later on, it was applied to situations in K through 12 schools. And so in 2012 or 2013, I went to Stanford and took a course in design thinking. And then I applied design thinking to one of my STEM education endeavors back in the States. And I started a mobile recreation vehicle that traveled around different parts of Texas, teaching kids about design thinking and robotics and engineering and that kind of stuff. So yeah, it's kind of interesting to see how the landscape has unfolded and where it came from. But what I really like about IDEO and the design school at Stanford is they've kept Ken's message of human-centered approaches, the human-first approach. So that means that the way that we think about design thinking today means that we start by thinking about the human and their needs. So that's why in design thinking, you'll see empathy as the very first step. So this is an image of Stanford's design school model. You may have seen this version floating around before. If you just Google design thinking and click on images, you're going to see a ton of these images pop up because they've become the most popular, especially in the field of education. But like I mentioned earlier, design thinking starts with the empathy step because design thinking is a human-centered approach where we don't just start making something for commercialization, but we first think about what that person might need, what their pain points are, what problems they might have. Then we move forward into the other parts of actually designing and creating something. So this ought to be familiar. You may have seen this before, but I want to now kind of go deeper and explain each one of these steps, but with an example. So the next part of this webinar is about the practical applications of design thinking. So the example that I want to give, and I wanted to kind of pick an example that was broad enough for everyone to have an idea of how they might be able to solve this problem. And it's a problem that's been solved before, and there's been many different solutions to this problem. So you might be familiar with some of the solutions already, but the cool thing about the world of design is that we can always iteratively change and adapt and make something new again. We can always modify and make something a little bit better. And as a matter of fact, in the world of design, most of the time, designers spend time improving things than inventing new things. So design thinking isn't necessarily about inventing a new thing, but more about improving things that already exist. So the topic that we're going to work through for this particular experience is, I want you to imagine a kindergartner, all right? So maybe you have your own children, or you know children, or maybe you were a kindergartner at one point in time. And one thing that a kindergartner needs in their life is a vessel to contain their beverage, water, milk, juice, whatever it happens to be. Usually this is sent in the school bag by mom and dad. It goes into the backpack, and mom and dad say, "Don't lose it. And make sure to bring it back home. We'll refill it and send it back with you each day in kindergarten." So there are a variety of different types of drinking vessels that fit the need of a kindergartner in this special case scenario. And some are good and some are not so good. So what we're going to be thinking about is, how can we design the optimal vessel the optimal beverage vessel for a kindergartner. Okay, so we're going to go through all of the stages and kind of think through what this process would look like. All right, so the first step that we're going to take is we need to empathize with the user. So first thing we're going to do is identify who the user is. The user, kindergartners. And to be more specific, we can say, kindergartners who attend school in a first world country. So that means that their parents have enough money to afford a drinking vessel that would cost anywhere between $5 and $20. Speaking US currency here, 5 or 10 euros or whatever. Okay, so that's the target demographic that we're going to design for. Okay, so what we need to do is, maybe it's been a while since we've known a kindergartner, so we need to get some firsthand experience with kindergartners. So I would say that we need to go and speak to a kindergartner and ask them about their cups, or we may just want to observe them. So we may want to, walk into the cafeteria at lunch and observe all of the kindergartners and take notes on the different drinking vessels that they have, which ones work, which ones don't work, which ones are hard to open, hard to close, spill all over themselves, these kind of things, which ones are too big for their hand, too small for their hands, etc. We're trying to get as much information as possible about the need and about the problem, okay? So in design thinking, there are several different ways that you can get this information. One way is through direct interviews, where you go and just speak to the people that you're solving the problem for, ask them a lot of questions, and really get to understand the problem. Now, sometimes that's not an option, right? So if we're doing design thinking in the classroom and we're trying to design, I don't know, something for an audience member that we don't necessarily have access to, then you can also do role playing and persona mapping, where you imagine the needs of that person. So even if, today we're not going to sit down with a kindergartner, I'm not going to bring one onto the screen and we're all going to ask the kindergartner questions. We're just going to imagine what that is like because of our previous and past experience with kindergartners. Okay, so the empathize step has the best effect if you can have direct connection with that person. If you can't and that's not available, the next best thing is to imagine it and to role play and to think about it. So the goal is you also want to get multiple perspectives. What one kindergartner says as the problem may be a different problem for someone else. So then you have to think about what are the elements that cause those problems. Well, some kindergartners are more dexterous. They can use all of their fingers and cut with paper and scissors. Other kids are, haven't quite developed those fine motor skills yet. So we want to think about a drinking vessel that solves all of those problems. It's got to be easy to grab, easy to hold, easy to put down. It doesn't fall over or tip over. It doesn't leak in the backpack. I'm just thinking out loud, kind of some of the problems that might exist with a cup, a drinking vessel for a kindergartner. So now as the designer, I'm thinking about, well, I need to solve all of these problems that exist with the drinking vessel. Okay, so this is just that stage of design thinking where we're gathering information, which is later going to lead me towards a final design. All right, so next, I've got all my data from my users, and now I'm going to define what to do next. And so it's during this step that I look at the problems. All right, so the problem I want to solve is that the cup sometimes falls over. All right, that's one problem. The other problem that I want to solve is that sometimes that leaks all over the place. All right, so those are the two that I've decided to tackle. Now, when you're a teacher and you're asking students to kind of narrow down a list, you may need to have some conversations with them and talk about and use some probing questions to better define, because we really can't solve all the problems. You can't make the perfect sippy cup or the perfect drinking cup that's perfect for every child, because every child is unique and different. So we want to kind of fix the biggest problems. And for me, when I watch kindergartners drink, those are the biggest problems I see. They knock the cup over and it spills because it's not closed correctly. All right, so those are the two I'm going to tackle. Now then, as the designer, I need to look at my own restraints that I have. So if I'm going to build something, there could be a restriction that I have on materials, on cost of those materials. There could be a timeline that I'm trying to stick inside of. So, I'm going to design this cup in the course of 2 weeks, the course of 3 weeks, the course of 3 months, etc. I only have access to certain prototyping materials like 3D printers and laser cutters. So I can only make a prototype version that will be made of this amount of materials, etc. Or maybe I don't have any of that stuff and all I've got is cardboard. And so those are the materials that I have to work with. So you have to define the restraints. And you as the teacher are going to help define those restraints because you know what the timing is, you know what materials are available, and you know the capability of your students. So you will help to set those parameters. But it's important that students are a part of that conversation so that they know how to use this part to solve problems later in the future. The most important part of this step is to define success. So what does success look like? Your prototype of your cup in this example should not fall over easily, and it shouldn't leak too much. I think that's kind of a healthy definition of success for this particular project, but whatever you're designing, you should always define like what does success look like in some way, shape, or form, but always leave room for improvements and enhancements. All right, so now I'm going to move into the next phase, which is the ideate stage. And this is where I use all of my creative energy to make as many possible solutions that could solve this problem. So I'm going to go to the drawing board, I'm going to get sticky notes out, whiteboards, and I'm just going to draw and label and discuss this problem. So I might draw 15 different designs. All right, so I might draw a cup that's the shape of a pyramid, because it's got a strong, sturdy base. All right, but maybe that's not so easy to tip over. All right, but I'm gonna keep that there anyway. Maybe I'll draw another one that has a weighted base. So the weight of it keeps it down. It's not going to tip over so easy. And then it's got a screw-on lid with a big, wide handle so the kids can tighten it easily. All right. So I would just come up with as many ideas as possible, put them all out on the table in front of me. And there's no wrong answers during this point. If I want a robotic, mechanized, Bluetooth-enabled sippy cup that my parents can check the status of during the day over a video call, whatever. I mean, just wild stuff. You put it out in there too, because nothing's too crazy for this part of the design thinking phase. It's meant to be creative, so don't say no anytime during this session. But what happens then is, let's say I've got 10 or 15 designs. Then I'm going to sit down and look at those designs, and sometimes this is done collaboratively. I actually prefer that it's done collaboratively. So I might have 3 other students working with me, 3 other partners, and we all look at them together. One way I like to do this is I like to take all the designs and put them on the wall, put them on a window or something. And then I might walk around with sticky notes and put, a note on each one of this. I like this design feature of this one. I like the lid on this one. I like the stability on this one. So then we have a discussion about the pros and cons of all of the different prototype ideas. But the goal to move forward from this stage is to converge all of those ideas into one singular idea. There's a couple of ways that this could go. It could be that one of the ideas was just so good, everyone looks at it and says, that's the one. That's the one we're going to go with. Let's move forward. Or it could be that, like, the lid on this one, the base on this one, the handle on this one, that's what we're going to build. So that discussion has to happen. And so you can't leave this stage until you have one final design choice. So I would recommend that at the end of this part of the design thinking method, that you have some kind of a basic rudimentary blueprint schematic of what that is. It doesn't have to be made in CAD. It doesn't have to have measurements and diagrams. It could just be a sticky note. But the most important thing is that everybody in the design team agrees on it. Like, this is the one we're going to build. Okay. So once you have that, then you move to the next step. And the next step is you build it. You actually make it. So you're going to prototype it. And so in design thinking, we don't ever really produce the final version that's going to be sold at the store. We produce prototypes of those. And what we call that is a minimal viable product. So that means it should look like it. It should be good enough that we can test it so that we can prove that it's actually going to be a useful product. So it doesn't necessarily have all of the details. It's not painted with a logo on it and have every perfection to it, but it's good enough for us to use. So if I was building a sippy cup or a cup for children of some kind, you could make it out of cardboard just as a prototype. You could make it out of PVC. You could 3D print it. You could laser cut elements of it and bring it together. You can combine different modalities and different materials. Now, if this was design thinking and we were building a digital product, then we could use other examples like mockups and wireframes, like if we were going to build a website, for example, as part of our design solution. So there's all kinds of different tools that are used for different scenarios. You got to figure out what's the right one for this particular scenario. Now, when you make a prototype, you may not necessarily know what you're doing. You may not know how to 3D print if you've never done that before. So you also need to kind of like add in a little bit of skill building with the 3D printing. And the first time you 3D print something, it may not come out right. So there may need to be some iterations in the prototype phase to get the prototype the way you want it to look that matches the idea from the previous step, from the ideate step, all right? So then once you finally do have that prototype that's ready, you take that prototype and then you test it. So I've got my cup here. I've 3D printed my cup. It has a strong base. It's got a lid that closes. And what I want to do with it is I want to now go and put it back in the hands of the kindergartners that I asked the questions to earlier and say, hey guys, I really listened to what you said about the cups that you didn't like. And so I designed a new cup that solves that problem. This cup, it doesn't fall down very easily, and the lid closes very easily so it doesn't spill all over inside your backpack or your lunchbox. Then I give them the cup full of liquid, and then I ask them to test it out, and they use it and give me feedback on that, okay? So it's really important that this step be taken. Otherwise, you don't know if your design works or not, okay? Now, a couple of different things can happen in this phase. You could hand it to the kindergartners, and the kindergartners are like, wow, it's so perfect. It doesn't fall over. I can shake the table and it doesn't move, and the lid closes and I can throw it in my bag. It's perfect. Or another thing could happen is that they put the lid on and then they shake it and it explodes. I don't know, just the worst possible scenario there. So then you're like, oh, wow, this really didn't work. So then at that point, you have to figure out which step of the design thinking process do you need to go back to solve that problem. Maybe there was just a problem with the prototype. The 3D printer printed a lid that was slightly off center. Okay, well, I just need to go fix that. But the problem could be so big that you really need to go all the way back to the define and think about how to reapproach this problem. So design thinking isn't meant to be linear. You don't just go in a straight line and then finish. You're constantly going back and forth. And designers often say that design is never done. There's always room for improvements. So really you kind of just get to a place where you're happy with it. Or in the field of education, and as educators, we have to have the end of the unit. All right, so then that kind of determines the end of when we stop. All right, so it's like, okay, we only have 3 weeks to work on this project, so it's got to be done at the end of the semester or whatever. So there are different reasons and different scenarios which might cause us to stop the design thinking process or to go back through it. I think it's important that kids should have that experience at least once to be able to go back and start over if they need to, because then they understand that design thinking is a way to solve problems, not just in the classroom, but for life. You can use this as a tool to solve any problem, all right? So yeah, this is the whole process kind of in a nutshell. But like I mentioned earlier, it's not linear. You can go back and forth between any step at any point along the way. And designers find that it's kind of a natural flow going back and forth in between these different steps. So once you have something to test and it's not working, then you need to go back and ideate or prototype, or maybe you even go all the way back to empathize and ask the kindergartners more questions. And you could say like, hey guys, the first time I spoke to you, you told me about the cup falls over and the lid. I designed one that doesn't fall over and the lid is working well, but now you say it's too heavy because the base is too heavy. Now you can't pick it up. So how could I design one that doesn't fall over, that doesn't leak, and that isn't too heavy? And now I have a new problem to solve. So it's cyclical like this. Another great thing about design thinking is that it's not just for design class. It's not just for sippy cups. Here are a few examples of how you can use design thinking in multiple different subjects. So I'm just going to read here, but you can follow along. In reading class, literature class, design a book blog showcase. Writing class, design a creative way to use AI to assist with writing. That's a whole other field that is just emerging. Social studies, design an interactive booth on a historical topic. Math, design a math board game that teaches a math concept. Science, design a renewable energy system. And I'm just giving one or two examples from each subject. There's so many more. Physical education, design a new sport that allows for wheelchair participation. So sometimes in design thinking, I'm a little bit more general and vague, like in science, design a renewable energy system. But in PE, I added specificity, design a new sport. That allows for wheelchair participation. So we're narrowing down the field of design so we can be more focused. That's also a handy way to enhance the design. Art, design a new art style that elderly people can try. So once again, we're narrowing the definition. Music, design a music video to promote after-school clubs. So in this example, I've added a purpose, design a music video to help after-school clubs or to promote after-school clubs. Foreign language, design posters of lunch menus in multiple languages. Computers, design a video game that allows children to explore geography. Now I'm combining subjects. It's infinite. There's so much cool stuff you can do with design. It's not just for the design classroom or the design and technology teachers. It can be used in concert in a variety of different ways across multiple subject areas. All right, so let me wrap up some of the content in the webinar by exploring some ways that we can go beyond design thinking. So you've probably heard about computational thinking, and computational thinking isn't necessarily just something that we do in computer class or in computer science, but this is another way to solve problems. And at BSD Education, we've actually are just about, in the next week, we're going to launch a new method called Decode, which is using the design thinking and computational thinking process together to solve problems. So stay tuned for that. But computational thinking is a way to take design thinking methods and break them down into smaller steps that are a little bit more like logical thinking. So computers only use logic to perform tasks. So computational thinking is kind of like more of a logical way to approach problem solving. So I think computational thinking and design thinking combined together is like the ultimate power duo of creative problem solving. So the cool thing about combining those two is that we are also taking divergent thinking and convergent thinking and putting them together. So if you've never heard those terms before, divergent thinking is a specific way of thinking where you're like open-ended, coming up with solutions, lots of ideas. And then convergent thinking is narrowing those ideas down into a single kind of choice or a single workable solution. So when you combine design thinking and computational thinking, you're using divergent thinking and convergent thinking at the same time. I think it's a really cool way to improve creative problem solving. If you want to dive deeper into design thinking, the Stanford Design School just recently, in the past year, has put out a series of books that go into more detail about design thinking in specific areas, like in language, like in the creation of geography and maps, different areas in the realm of social emotional learning. So I'm going to share a link to this at the end of the webinar, just so that if you're interested, you could look at these. But I've read at least the first 4 books in these series and find them to be really intriguing and interesting to deepen my knowledge of understanding. My favorite one so far is this orange one. It's called Design for Belonging. And so it's a social emotional approach to design thinking. So we're thinking about equity and accessibility for design and how we communicate that so that design is more inclusive. So I highly recommend that one. And I'll share the link here in a moment. But I want to talk to you just for a moment about what we do at BSD Education and get you involved with some of the things that we're doing and free projects that we have available. So we kind of infuse design thinking into our projects, into our curriculum, into our courses. And this is an example of a project where students would be learning HTML, CSS, and JavaScript to build a website. So, any student can learn those skills and build a website. But what we ask students to do is to build a website for a community organization in their own neighborhoods, in their own local communities. So let's say you live in Hong Kong. As the teacher, BSD would ask you to research and find a local organization, like a nonprofit organization that needs a new website. And then your class would interview the owner of that nonprofit and build a website for them. In this example, we have the Kind Hearts Animal Sanctuary, which is an animal shelter, an animal rights organization. And so students would begin with empathy by asking what do they need, and then they build the website and so on. So it takes this digital skills learning, like I need to learn how to use HTML, CSS, and JavaScript to build the website, but now I'm building it with a purpose. And now I'm using design thinking to solve a problem. And now when I'm done with this, there's going to be a real organization that I served, and they have a website that we designed together. So we just kind of make things more holistic that way. Just to kind of acquaint you with BSD Education's suite of products, we have a free trial that's called BSD Start, where you can set up 30 student accounts and 4 hours of coding projects, similar to what I just showed you. If you want access to more of our curriculum, we have BSD Teach, which is a subscription, which allows you to have those same 30 students, but with much more curriculum. Then if you want the whole school to be involved and use all 600 hours of our curriculum, we have BSD Build, which comes with ongoing support, live chat, etc. But if you want to just kind of get started with some of our free content today, I suggest you check out BSD Start, which has these free projects. One is an AI webcam image classifier, which sounds like something really difficult, but we make it easy because we have a pedagogical approach in which you are learning one step at a time, building and scaffolding knowledge. Another project is called The People Who Inspire Me, and another one is called Trivia Game Maker. I'll share the links so you can explore more on your own. Thanks for joining me today. I hope that you learned something new about design. But I'm going to just stop sharing my screen now, and I'm going to share the links that I mentioned earlier. Now would be a great time for you to put any questions that you may have had into the chat. Let's see, I've got too many windows open. There we go. All right, so I've just posted into the chat the link to the history of design thinking, which I mentioned earlier in the webinar. I've put a link to the Stanford Design School books that I mentioned, and I've also put a link to BSD Start so that you can start your free trial with 30 students and use our products. Great. I'm also going to stop recording now. Thank you all, and we'll catch you next time.